Dear participants, our next session, session 11 of this FTP. And today's second session is about to start. Our speaker is just trying to join the event. I think in few seconds they are about to start. The moderator of the session, MATLAB, is already joined us. So we are waiting a couple of seconds for Mr. Danish. Okay, Mr. Mohd Danish, are you able to listen me?
Yes. Am I audible?
Okay. Yeah, you are audible. So, Mr. Danish, Mr. Mohd Danish,
Yes.
faculty member of the University Polytechnic, and he is today's lecture. So, over to you, MATLAB. Please introduce our today's second speaker.
So let us all welcome a very dynamic faculty member of Aligarh Muslim University, Mr. Mohd Danish. He is working as assistant professor in University Polytechnic in the civil engineering section, Aligarh Muslim University. He graduated in civil engineering in 2012 and completed his master's in 2014 from the Department of Civil Engineering, Aligarh Muslim University. Currently, he is also pursuing PhD in civil engineering. Since his graduation days, Mr. Danish has been involved in various research activities and he has published various papers in the journals of repute and international conferences. His field of interest is soft computing techniques, artificial intelligence, scour prediction, computational fluid dynamics, and flood frequency analysis. His research papers have been published mainly in Elsevier, Indian Water Resource Society, Aquatic, Procedia, Springer, etc. He has received 2 gold medals and he has a patent in his name. So now he will be taking up this lecture. This lecture is going to be very interactive and interesting. So he has command over MATLAB and Octave. So now, sir, welcome. You may start.
So I have shared my PowerPoint for the presentation. Is it visible?
Yes, Mr. Danish, you can speak.
Good afternoon, everybody. Today, topic of my presentation is programming in MATLAB fundamentals. So I will be discussing the fundamentals of programming in this lecture and its features, various syntax, and the concept behind the programming. The MATLAB is a very simple method for doing the mathematical calculations as well as to write various programs so that you can execute those mathematical calculations and mathematical expressions and you can solve it where it is very difficult to solve it manually. So this is a very simple tool, just MATLAB product. It is a very interactive tool. The expression in this tool, an expression is entered by the user. The user is me, you, and everybody. So this expression is entered by the user, and then MATLAB responds, read those expression, and then responds with a result. Now in MATLAB, since this particular lecture is focusing on the scripts and functions and writing programs in MATLAB, so it is possible to write scripts and programs in MATLAB. The scripts and programs are nothing but the group of commands that this MATLAB is going to execute for you. Whatever you ask the MATLAB to do, it will execute those commands. Okay, but for executing those commands, you have to know the syntax, the proper syntax and proper method to execute those commands. Now, MATLAB is also capable of evaluating expressions symbolically, as discussed in your previous session, how to do this, how to use symbolic toolbox. So I hope you understand this, how to evaluate the expression symbolically. MATLAB is a very versatile toolbox. It can work on various optimization techniques. Other applications of MATLAB are in simulation. You can run simulation with the help of Simulink. You can also work in image processing and image recognition also. MATLAB has a very wide range of artificial intelligence tools. You can use all those tools: artificial neural network, neurofuzzy, genetic algorithm, and genetic programming. All those optimization tools you can use MATLAB. And in the latest versions of MATLAB, you can find a toolbox, a separate toolbox for deep learning. So you can also do the deep learning neural network in this MATLAB product. So in this particular lecture, I will be focusing mainly on writing scripts and programs, and to discuss various syntaxes and various commands that will help you in doing your research work, in doing your whatever work you are doing, you are using with the help of MATLAB. So that will be helpful. Those commands will be helpful in your work. This is the overview of the slides that I have. I will discuss. I will give you just a quick review of the various data types. And then I will discuss how to create and work with tables in a MATLAB. Then I will give you a quick review of loops and logical statements that we have to use in our programming to make it more executable and more user-friendly. So these loops and logical statements will be very useful. And then we will work on hands-on training on scripts and functions also. Okay. The basic numeric data types are single data types, double data type. These are single precision and double precision. Int 8 is the integer of 8 bits. Int 16 is int 32. What most of the works that we do for integers is int 32. This int represents the integer value, and 32 represents the bit value, the memory it will take. And you can calculate that what is the minimum and maximum value of this integer, of integer 32 or integer 60. Then int 64, you can, if you need a higher value of your integer, then you can use int 64. Most of the work that we do regularly is just comes under int 30. Then uint 8 means unsigned integer. This is signed integer with both the values, positive as well as negative values. But in unsigned uint, these are only the values from 0 to up to the maximum value that this particular integer represents. I will show you in the MATLAB command how to calculate the maximum and minimum value that will represent by this type of data. Then unsigned integer 16. Unsigned integer 16 is again represents the integer value from 0 to the maximum value, the highest value it represents. And similarly for uint 32 and uint 64. Another data, when there is a number which does not exist, then MATLAB give you an representation. This is not a number. It represents this is not a number. So if there is no number, or the number cannot be defined by the MATLAB interface, then this will return the value and an. So you have to be very careful in your programming that this does not come in your results. Okay. And again, this is infinity. This represents infinite value. So you have to be very careful when you are working in a real value, real arrays, then you have to be careful about the infinity also. Now the what is the mean of int 8? It means that it uses the 8 bits to store your integer. So 1 bit is used for your sign, that is positive or negative, and 7 bits will be used for storing the numbers, that integer value that it represents. Okay. This is useful when you write a very big program, and this program, then you have to, you can also convert your program, your script file into a executable file. So sometimes it happens that since the MATLAB interacts with a large number of data, and if your file is very large, it will be very difficult to execute it, or it will be very difficult to run it fast. Okay, so to make it faster, sometimes we need to use those figures, those values which use less space. So in that case, we need this type of representation. We can convert from int 32 to int 8 or vice versa. So this is useful when you write a very bulky program and to save space. Okay. So the type u int 8, it means unsigned. So this value will range from 0 to only on the positive side. So 0 to the value, the higher value it represents. So it means u int 8 means the integer will be 2 raised to the power 8. Okay. So there will be 256 integers. Okay. Another data type is characters and strings. Now, while working in the MATLAB interface, there are various data which are simply numbers. Okay. So like 1, 2, integer or real numbers. Okay. But many a times you come across various variables and various characters because when you write a program, you have to interact with the user. Okay, that user is using your program, so you have to interact with your user. You have to tell him that what he has to do, and he will tell you what the program will do. Okay, so you have to interact with the user. So many a times the user will type simple expressions like yes or no, true or false, or when you ask, suppose you ask your user his name, so he will type the first name. So all these character values will be stored in char. If it is a single character, like a single alphabet A or single alphabet B or single alphabet X, then it will be stored as a character. And if it is a combination, a single word or a sentence, then it will be stored as a string. Okay, so this will be very useful when you interact with your user. He will give you some answers, and those answers will be stored either in character or in strings based on the word or a single alphabet that it represents. Okay. The character or the strings is always represented under single quotes. So if I write a simple 2, so this is a numeric value. But if I close this under single quotes, then this 2 is no more an integral value, but this is a value, this is a character. This represents a character 2. Okay, so this is the differentiate between a character and a integer value. Suppose I write A, simple A. So your MATLAB, what MATLAB will do, MATLAB will return the integer value associated with this alphabet A. It will not display this alphabet as A. If you want to display it as A, then you have to close it under single quotes. Then MATLAB will understand, okay, that this is a character value. So a character value or a string value has to be always always represented and closed under single quotes. Okay, otherwise the MATLAB will convert it into the respective integer or double value. Okay. Another data type that has been discussed in the previous session is arrays. Arrays can be of two different categories: vectors and matrices. A vector is simply a scalar value. Suppose you have a single digit value, single digit as say 2. This is a one-to-one vector. A 1 cross 1 vector. Okay, this is a 1 by 1 vector. Now, if you represent a single row, then a row matrix. So in MATLAB, we call a row matrix as a row vector. It is represented by a vector. So a one-dimensional matrix is always known as a vector in MATLAB. Okay, a two-dimensional matrix is known as a matrix, and collectively they both are known as arrays. Okay, they both are known as arrays. So whenever we call array means both vector means a one-dimensional array, and a matrix means a two-dimensional array. So there are various ways to create an array. This is a block diagonal matrix. Okay, BLKDIAG. This is a command in MATLAB. With this, you can create a block diagonal matrix. This will create a diagonal matrix. Okay. So the numbers or the digits will be on the main diagonal of the matrix. So this will create a diagonal matrix. Line space or log space will give you the values. Suppose I write line space 1, 2, 5. Okay. So it will represent the execution will be 1, 2, 3, 4, 5. The numbers ranging from 1 to 5. So how this will give you the line space will give you the results like this. Okay, so you can create an array, one-dimensional array or two-dimensional array as well. Ones will give you the matrix of ones only. Random will give you the numbers at random. So whenever you type random, so it will give you a random number. So a number of times, suppose if you do it in number of times, so it will you have to reset it to its original value. Okay, then it will work correctly. Okay, zeros will give you the array of zeros only. So this is how you can have different types of arrays. This is just a common command that we use. Generally, we use line space, okay, because it is a linearly spaced arrays. Now, I am just discussing those syntaxes which I am going to use in my script. Okay, so I am skipping to most of the commands because all those functions and all those commands must have been discussed in the previous session. So I am just discussing all those commands which I am going to use in my hands-on training. Okay. Now another task in our MATLAB programming is to create tables. Now, whenever we create a string or we create an array, it stores the variables in a data graded form. Okay. Now, if suppose we want to export our results, whatever the results we get, that will be stored in a in the variables, and I want to export all those variables, all those results to suppose in an Excel sheet or a spreadsheet. So for that purpose, we need to create some tables. Okay. So how to create tables? The usual syntax for creating a table is this. Suppose this INP main input, INP means input main, is a variable that I have created here. Okay, and then put equal sign and curly brackets. Okay, so remember to put this curly bracket, no square brackets, no parentheses, but these brackets. Okay. Then the first line, which is separated by comma, represent the first row of that table. Suppose I want to write a text, a title in the table, and the title is design data. So this table, the very first cell of the table is the text, which is design data. Now this double quotes means this cell is blank. Okay, this cell is blank and this cell is blank. So my first row having 4 columns, 1, 2, 3, 4, separated by commas, and then this row will end here. In my second row, the first column is serial number, then separated by comma. Next is description, then value, then unit. So this will be the second row, separated by semicolon. So here the second row ends, and then I give serial number 1 here. Then so you have to write your table like this, and when you end your table, you have to end it with the same curly brackets. So you have to close your brackets here. So the MATLAB will understand that your table starts from here and your table ends up here. So remember to end your command with a semicolon so that you can suppress the execution of the commands. If you don't put the semicolon here, the command will execute in the command window. So if you don't want to execute your command in the command window, so you have to suppress it with the semicolon. So that is how I have created this. Command will create a variable. In this variable, this whole table will be stored. Okay. I will use the same command in the MATLAB command window and will show you how this will work in the MATLAB interface. Another variable is FM. In FM means forces and moments. Suppose I am doing a design calculations, and in that design calculations, I want to store forces and moments, and I want to tabulate all the data for the forces and moments. So how I can do it? I have to mention the rows and columns in the similarly just I have used in the previous command. So I will mention the rows and columns separately, and then we'll end the table with the curly brackets. Okay. So that is how the MATLAB will understand that there are 2 variables, FM and input main, in which this whole table is stored. So your MATLAB will store these 2 tables, but you have to make a separate string so that these variables will be stored in that string, because now here the input main is a variable that is stored only in MATLAB workspace. This variable is not stored in some arrays. Okay, this is only a variable that is created in the workspace, and this table is associated with that variable. But if you want to store it in a string, you have to make a string. So the command for making a string is this. Calculate is a string, dot input. It means that calculate will be a string in which this variable input main will be associated. So I have created a variable input main inside my string calculate. Okay. And I have equated this with the original variable input main. So what this command will do, this command will create a string calculate. Okay. And within that string, it will create a variable input main. And now this is an empty variable input main within the string calculate. So I have to store some value. So that value will come from the table that you have defined earlier. So this will be, so you have to equate it with the variable that you have created earlier. Now your created variable will be stored as a string. Okay. Before that point, your variable was only in the MATLAB workspace. It was not stored in a string. Now this is stored in a string. So this is how you create a string, okay, and store your variable, and this variable will be stored in the string like this. Similarly, for the forces and moments, you can create a string, you can create other string or the same string. I have used the same string calculate here, and within the same string I have defined two different variables, that is input main and fm, and that I have associated the variable to this newly created variable calculate or data. You can give any other name to this. I have just, for the sake of simplicity, I have taken the same name fm and fm over here. You can change this name also. You can use whatever the name you like. Okay. Now these two commands represent the creation of string only. Okay. With these commands, you have just created a string, and within the string there are two variables, input main and fm, and these two variables contains the two tables. Okay. Now this string have to be stored in a syntax of tables. Okay. So in order to save it as tables, there is a command save. With the save command, you can save your results. Okay. So I have created a table named results. The title of the table is results. .mat is the extension for the tables. So what will it do? This command will tell the MATLAB to save a table name results. Okay. So this will create a table named results. The title of the table is results. And what is the content of this table? The content of this table is calculate. So what it will do, it will call the string that you have earlier created, the name calculate, and the whole string is now saved as a MATLAB table. Okay. So here you have created a table. Okay. So all these commands you have to follow in order to create a table. Okay. And then this table will be can be exported to the external spreadsheet or PDF or text file or CSV file in any other format you want. But first you have to calculate the tables. This is important when you have your program and this program does some calculations, and all those the results comes out from those calculations. You have to store in a spreadsheet. Then you have to do this. You have to use this command. Okay. All this has to be done in MATLAB, because the MATLAB considers strings and tables as a two different data types. Okay. A string is a separate data type and tables are different. Okay. The behavior of both of these strings and tables are different in the MATLAB workspace. Okay. The table is a collection of all the strings. The strings is collection of different variables. Okay. So this is how the MATLAB workspace works. Okay. Now suppose you want to load your table, the table that you have created, and you want to load all the data from the table. So you can use the load command. Okay. And the table that you have just created is results.mat. So you just type the results.mat and it will load the tables, the created table in the MATLAB workspace. So I will demonstrate these commands in the command window, okay, during the hands-on session. So another important topic is loops and logical statements. These loops and logical statements many a times we come across the problem where we have to run loops. Okay, because it is very difficult to run do the manual calculations. Suppose you want to create some variables, okay, and the variables are based on the number of data that you have. Okay, so one way to create the variables to do it manually in the script file. Now, when the data changes, the number of variable changes, and you have to do it manually each time. Okay, so to save that manual work, what you can do, you can use loops. So there are certain loops that you can use. There are for loops, there are while loops. The for loops and while loops are frequently used in the MATLAB. So the syntax of for loops is this. Here I have defined a variable n, and I have associated the scalar value 5 to this variable n. Okay. Then I have created a variable run product, run PROD. This is run product, and associated the scalar value 1 to this run product. Okay. I will explain why I have associated this value 1 later on. Now the syntax of for loop is this. You have to start your loop with the word for, then followed by the condition. Okay. The for will tell the MATLAB that the for loop has started here, and the condition will be written afterwards. Okay. The condition here is this I will range from 1 to n. N here is 5. So this I will range from 1 to 5. It means the I is 1, 2, 3, 4, and 5. Okay. So this will tell you that the value of y is from 1 to 5. Okay. So our loop, the based on this value, just generally I is used. We denote this value I for the number of times the loop we have to run. Okay. Suppose you have to do 1,000 iterations for a particular calculation. So this I represents the number of iteration for which the for loop will run. Okay. So run product is equal to run product multiplied by I. Okay. So initial value of run product is 1. Okay. Initial value of I is 1. So 1 into 1. This will give you the answer run product equal to 1. Okay. Then next, this will not end. Okay. This will not end until the I will reach to its highest value. Okay. Next value for I is 2. So now it will take the I is equal to 2. It will put run product is 1. I is 2. Then 2 into 1. It will give you the answer run product equal to 2. Now the value of run product is 2. Now again, it will take I as 3. Run product as 2. 2 into 3 is 6. And so on. It will go on doing the same iteration up to the time, up to the value of I reaches to its maximum value, that is n here. Okay. And when it reaches to a value of n, as 5 in this case, it will end your program. So this is how you use the syntax of for loop. The for loop must be terminated with the command end. If you forget to use this end command, then your for loop will give you a error in the MATLAB command. Okay, so you have to terminate your for loop with the command end. Okay. Now, if you think clearly what this program represents, this program is nothing but a factorial. Okay, the factorial of n. So whatever will be the n, this will give you the factorial of that number. Okay. In MATLAB, there is a separate command for the calculating the factorial, and that is factorial. And the argument will be the n. Whatever will be the value of n here, this will be the argument of that factorial command. So this is how you can create loops. Another case is switch case. In switch case, when it is used, suppose you want your user to give some answer. Suppose you want your user to enter his name, his full name. Now, what it will do, it will ask the user whether he want to enter. This is a question. I will explain it while using the hands-on training. What does it represent? Okay. This is a dialog box. This dialog box, the display will be, do you want to enter your details? It will ask the user, do you want to enter your details? If the user answers yes, then it will ask the user to put its name. And he has to enter his full name. Okay. If user gives the response to no, then the MATLAB will tell you that user details not entered. And if the user press cancel, then it will return to the original program. So in switch cases, switch case statement works where you have to interact with your user, and based on the answer given by the user, the switch will be will transfer the case accordingly. Okay, whatever will be your answer, the case will be accordingly. Okay. So here there are two possibilities: yes, no, or cancel. Either user can choose yes, or he can choose no, or he can choose cancel. If he choose yes, the command after this case will be run. Okay. So this is the statement. This is the body. Okay. Here you have to enter the statements. Similarly, there is a separate case no. If the user use no, then the command will be this. And if the user use cancel, then the command will be this. So this is the syntax for the switch case statements. Okay, and again, every loop and statement must terminate with the command end. Okay, so this switch will end here. So in our,
sorry to interrupt you. There is one query that are you going to show it on MATLAB also?
yes.
Okay, one of the query. So Mr. Danish will definitely show it also on MATLAB. Thank you.
Yes. Another statement is while loop. All these loops and statements and all these creating tables and working with matrices and calculating the size of matrix and indexing matrix, all this I'm going to demonstrate in the MATLAB environment. Okay, I'm just give you a quick overview of all those commands that I'm going to use. Okay. Another loop that we use is while loop. The difference between while loop and for loop is that the for loop runs until this condition is met. Okay. And while loop, the similar case is for the while loop, but while loop can go on and on and on until if we do not provide any condition, it can move on and on. We have to provide the condition over here. Okay. The execution time of for loop is faster than the while. Now, what does this this command shows us is that we have created a variable high over here, okay, and we have assigned the value of 500, scalar value of 500 to this variable high. Okay. Then we have initialized our value to 0. Okay. And then the another value fact means factorial or factor is assigned has been assigned a value of 1, scalar 1 over here. Okay. So what it will do, while we have to start our while loop with the syntax while and followed by the condition. Now the condition is the fact this variable fact should be less than or equal to high. Okay. If this condition is met, Okay, if this condition is met, then the command will go into the while loop. Okay, so all these statements will execute. And if this condition is false, if this condition does not satisfy, then what will happen? Then the while loop will not be executed and it will go and execute the other command outside of this while loop. Okay. So what it will do, if it will check the condition whether this variable fact is less than or equal to high. Okay. If it is true, then it will run the commands that is written in the body of this while. Okay. And after calculating all these, it will go up to the value when this condition cease to exist. Okay. When the factorial is not less than or equal to high, then this loop will end and the value after that while loop will be executed. Okay. Now this program is again a same program that we have run in our for loop, and this represents a factorial. Okay. This is how you can calculate a factorial. So the same factorial command can be run in using for loop, and same factorial command can be used by running the while loop. Okay. So this is the syntax of the while loop. So I have discussed three conditional statements: for loop, while loop, and switch and cases. Now the main title is the programming in MATLAB, and programming in MATLAB cannot be done by writing the script files and function files. Okay, the extension of the script file is .m file. The extension is .m. Okay, like the Word files are having extension .doc, PPT file are .ppt, PDF file are .pdf. Similarly, the files that are written in MATLAB are having the extension of .m. So that's why we call the files as M files. Okay. So scripts are written as M files. Okay. They must have the extension .m. Only then it is called a script file. Similarly, function file must have the extension .m. Function file is also written like a script file, but there is a slight difference while writing the script file and function file, and that will differentiate between the two. Okay, I will tell you how to write a function file and how to write a script file. Okay, what is a script file? A script file is a collection of commands. Whatever the commands that your MATLAB program will going to run, you can write all those commands in a single file. Okay, so that single file is known as a script. Okay, thus the script file uses the base workspace. Whatever the workspace your MATLAB is using, the same workspace has been used by the script file. Okay, there is no separate workspace for the script files. Okay, it will what it will do when you run your script file, it will go through all the commands that has been written from the start till the end, and it will execute those commands and represent the results in the command file. Okay. Function files can be written similarly to the script file. There is a slight difference. You have to start the function file by writing a statement function. Okay, in the very beginning. Okay, what the function will do? The function will take the arguments. Arguments means the inputs that the user can give. The user can assign certain inputs. Those inputs can be transferred to your function, whatever the function you have created, and the function will give a single output, and that output can be represented in a single variable. Okay, the working of the function file is that you give a single output, a single input, and this function file will run all those inputs based on the command that you have defined, and it will give a single output. Okay, the function file can be local, can be nested, can be private, can be anonymous, Okay, all these the different kinds of functions. Okay. Similarly, the functions are passed and loaded into the memory, and then it will be executed. Okay. What is an anonymous function? The function can be written by two methods. First, you can write a file, a separate function file, and save that function file with the extension .m file, and then you can call that function file each time you want to use that function. Or the alternative method is that you define your function, that is known as the anonymous function, within the body of the script. Okay, so if you have or in a command window or in the body of the script, you can define the function then and there. You do not need to define this function in a separate file and then call with the syntax, call that function with the syntax. You do not need to do that. You can define your function within the body or within the command window and then use that function to execute your output. The example is that suppose we have created a function f1 over here. Okay, the syntax is @xy. It will tell you that the function @ means it will tell you that f1 is a function based on the two variables x and y. There are two variables, and this is the expression for this function. This function in the first row, it will calculate sine pi into x. So whatever will be the value of x, it will pass on that value over here and it will calculate sine pi x. Second, in the second column, it will give you cos pi y. Whatever the value of this y, it will give you the value y. It will store this value y over here and then it will evaluate cos pi y. In the third column, it will calculate the tan pi xy. Okay, and then after calculating all this value, it will represent the answer of this function. Now, in order to calculate this, you have to give some arguments, means the value, integer value for this x and y, because it accepts only two variables, so you can only give two variables. Okay, so the variables x, the first variable is x, so x is 0.5 separated by comma, and value of y is 0.25. Okay, and then what it will tell the MATLAB that the function f1 and the arguments are 0.5 and 0.25, and it will again go to this expression and calculate the value for you by by substituting the values of x and y over its place. Okay, wherever you have defined your variable, the value of x will go to the value of x and value of y will go, and then the answer will be executed, will give you the answer. Okay, like this. So the first is the answer of sine pi x. So one is the answer of sine pi x. Second is the answer for cos pi y, and third, it is the answer for tan pi xy. So this is how you can define an anonymous function, and this is how this anonymous function is executed. Okay, this is an example of another function which accepts only one argument. Okay, that is x, and this is the expression for this function. So based on that, this will give you the answer. Okay. Now, while writing the function file, there are some rules that you have to keep in your mind so that your function will work correctly, okay, will be executed. If you do not keep those rules in mind, then what will happen? That your function will show some error, okay, and your function will not be evaluated. So you have to keep all those rules in mind. The rule is that the function must be represented by the the function file must be started with this syntax function. It will tell the MATLAB that this is categorized as a function file. Okay, and function file, then you have to associate an argument with that function file. Argument means the input that will be going into that function. Okay, And the function must have an output, because the function will return a result. Okay, and that result will be represented by an output argument. So there must be some output argument and there must be some input argument. If this input and output argument are absent, then this function will represent an error. Okay. The name of the function, followed by this first syntax function, you have to write the name of the function. And the name of the function must be the name of the file. Whatever the name you have given to your M file, the same name should be the name of the function. Okay. If you change your name and the change of the name of if the name of the function and the name of the M file are different, what will happen? It can give you the error message. Okay. So the name of the function and the name of the file must be same, and there must not be any space in the name of the function. The name of the function should be a single word. Okay, there should not be any space in the name of the function. Then you have to define the input arguments in parentheses. Okay, this will tell the function file that this is the input argument. Then you can choose the number of arguments that is going to be act as input. There may be 2 arguments, there may be 3 arguments, there may be multiple arguments, there may be a single argument. Okay, so all those input arguments must be defined in a parenthesis. Okay, so whenever you call your function, whatever the argument will be in the function, that will go into the input arguments. Okay. After that, you can write the statement or a comment which describes your function. Because if you give that function file to any other user who is not who does not understand your commands and the functionality of your function, so you have to tell the user that what this function is going to do. Okay, so all those statements which are going to help your user, so you have to write some comments so that the user who is using that function can press the help button and can search whatever the comments you have written. Okay, so this must describe your function, what your function will do, what is the purpose of your function, how the syntax of the function will work, and you must have to give us some example, some working example, so how to execute that function, how this function will work. So all those will be described by using a comment. Okay. A comment can be written by using this percent synthesis. Okay. Then the main body of the function includes all these statements. Whatever your function will going to calculate. Suppose your function is going to calculate the factorial. So all those variables and all those expressions that will help the function to calculate the factorial, it will be in the body of the function. Okay, and this calculation must be associated with a single output or a multiple output, but it has to be associated with an output argument. So there must be an output variable also, and that output, after the output, the function must end by this statement end. Okay, this may not be necessary in some cases. You can, if you forget to write end at the end of the function, then it will execute. Okay, but in some cases it will create a problem. So you have to terminate your function file with the statement end. So this will tell the MATLAB that here your function is ended. So in MATLAB M file, this is how this whole MATLAB rules, function rules are written. Suppose there is a file name function name dot m. Okay, this is the extension of the file dot m, and the name of the function is function name. Okay. So your function file must start with function. Okay, this is the output argument. Whatever the value of your output, the value of output is stored in output argument is equal to. Now the name of the M file is used as a name of the function. Okay, it is function, and in parenthesis your input argument. Okay, whatever the inputs you have, suppose you want to calculate the factorial of 5. So input argument will be 5, function name will be factorial, and output will be some any output, say y. So y is equal to factorial in parenthesis 5. So this is how you write this. Then followed by your comments, how to use this function. Okay. In comments must include some examples and a brief description to describe this function. Okay. Then all those statements which should be used to calculate the factorial or whatever will be the purpose of your function. And the function should be terminated with the statement. Now all those syntaxes and all those fundamentals, those concepts that I have described in my slides, all those I am going to demonstrate in MATLAB, doing the hands-on. Okay, in MATLAB, I am going to describe all these. I am going to calculate the range of integers that can be stored in the types uint16 and int16, and then I am going to calculate the maximum and minimum value of these integers. Okay. Then we can also calculate the numerical equivalent of the character t, or we can calculate the character equivalent of the double integer printed value. And I will do the hands-on training on script and options. So now I'm switching over the MATLAB. Okay. This MATLAB window is visible.
No, sir, it is not visible. Your screen is not visible, sir. Yeah, it's visible now.
Okay. Thank you.
Yes.
Okay, I have shared all these M files with you. I have shared it with the coordinator. The coordinator will give you all these M files. Okay, and there you can understand how these codes are written, and you are free to change all the codes and do some workaround in these script files so that you can learn better. Okay. The first question is that calculate the range of integers that can be stored in the types of uint16 and int16. Okay, so how to calculate the range of integers? Okay, the range of integers can be calculated by using the command, by using this command. I have created a variable ui16. ui16, this variable I have created. And to calculate the value, integer value for this unsigned integer 16, so I can calculate by it 2 raised to the power 16. Okay, so I press enter. It means that it refers value 65,536. It means that the maximum value of this integer is 65,536. The integer will start from 0 up to this value. Okay. If I want to know the value of int 16. So how to calculate this int 16? This can be calculated. This is the variable in16, okay, equal to 2 raised to the power 16 divided by 2, because the unsigned integer having only the positive values, but the integer command having both the negative and positive values. So divide by 2 means negative values as well as positive values. So the values will be from minus 32,768 to 32,767. Okay, so the integer 16, this integer 16 will contains the integer value from minus 32,768 to 32,767, all those values. Okay. Now I can verify this by what is the minimum value of this int 16 and what is the maximum value of this int 16. So the minimum value should be minus 32,768. Okay. So int min int 60. So the minimum value, int min means the minimum value of integer is minus 32,760. Okay, so this is telling the MATLAB that to calculate the minimum value of integer is stored in int 16. Okay, this is what is the meaning of this command. If I write int max, it means the function is calculating the maximum value of integer, and int 16, the input argument is int 16. Okay. Press enter. So it will go 32,767. Okay. The maximum value is this. So similarly, you can calculate the maximum and minimum values of integer and the whole range of these of all the integer, whether it is int 32, int 64, int 32, int 64. You can change the argument here and you can calculate all the values. Now another question is find the numerical equivalent of the character T. Okay. So how to calculate this? Now the character, the default data type in the MATLAB environment is double. Okay, double precision. So if I have written a single character, say T, and I want to calculate the numerical equivalent. So what I will do, I will put the argument T, okay, and this command will give you the equivalent value of double representing the letter T, alphabet T. Okay, press enter. So this 116, this value 116 is associated to the character T. Okay, if you want to write the character which is representing this 116, so what you will do, you will just write char. It will convert the value of 116 to the character value. Okay, so here it is T. So this is how you can convert the character value to the numerical value and the numerical value to the character value. Okay. Another is find the character equivalent of 112. This is you can do yourself. Okay, you can calculate the character equivalent of 112 by using this command char. In parentheses, you can write character 112. If you want to know what is the integer value or the equivalent numerical value of alphabet A, then just type double A, it will give you 97. And if you want to know what is the character equivalent of 97, so many times these two commands comes in handy while writing the MATLAB program. Okay, that's why I have discussed it.
Sir, I think there's a doubt. There is some doubt. And there's a chat box. Dr. Jyoti Sinha is asking something.
Yes.
Dr. Jyoti Sinha.
Yes, sir. Sir, I have one query. As you told, this unsigned integer are having 65,536 and signed you said 32,768. So I have confusion this. If we take without signed integers, it means minus sign, minus say like minus 5 to plus 5. This will be more. And if I'm going only positive value, so it will be 0 to 5. So
Yes,
I
yes.
have some confusion in these two things, sir. Please.
Okay, let me tell you again.
Yes, sir.
Unsigned integers means the values only positive values. Okay, only positive values from 0 up to the maximum value. Okay. So, coordinator, can you please switch off? Yes. So unsigned integer means the integer values from 0 to the maximum value of that particular integer type. Okay. So u int 16, the maximum value of u int 16 is this 65,536. So if you want to calculate the minimum value of this, what will be the minimum value of this integer type? So just write int min, okay, and write u int 16. Okay. This will give you the minimum value. So the minimum value is 0 because u int represent unsigned integers. Okay, the minimum value will always be the 0. Okay, it will start from the 0 up to the maximum value. Now, what was the maximum value? The maximum value was 2 which 65,536. So the maximum value should be this. We have to check our calculation. Okay. So in order to check our calculation, I just write the command over here, u int 16, and I will try to calculate maximum value. So the maximum value is 65,535. Okay. One less value from this. Okay. Because the maximum value is this, so the integer will be the value, one less value from the highest value. Okay. So the maximum value will be 65,535 because one value is stored as a 0 because 0 will always be there. Okay, so that's why it is one lesser value. So that is how you can calculate the maximum and minimum value representing. If you calculate say u int 32, so maximum value for unsigned integer, remember always start from 0 till the highest value. The highest value will be this. Okay, this value. This is a very large value. So this will be the highest value represented by this type of integer. Okay. So most of the time we work under this range, int min. Most of the time we use int 32 type integer. Whenever we work in integer type. Okay. So the minimum value will be minus this much. And maximum value will be int 32. So remember, int means integer will consist of both the value, positive as well as negative values. Okay, and unsigned will only carry minimum value 0 and maximum value the maximum value. Okay, I hope this answers the query. Now another, if your query is still not answered or you have not understood, you can ask it. Okay. Now vector and matrices indexing. The indexing is very important while doing while compiling the MATLAB program because many times you need to call your syntax. Okay, you need to call your variables. Okay. And the variables, the data values are stored in your variables. So what you need to do, you need to call all those variables and the value which are associated with that value. So for that purpose, indexing is very helpful. Indexing means just calling the values of those of the vectors and matrices. Okay, I show you an example. Suppose I define a variable vec, okay, and 1 to 5. What it will do? This command will create a variable named vec, and in that variable there is a row vector which is from 1 to 5. Okay, so this is a row vector from 1 to 5. Okay, in my slides I've shown that vector variables are one-dimensional arrays. Okay, so either it is a row or a column or a single scalar. All these are represented by a vector. Okay, so suppose I have defined over a row vector over here, which is starting from 1 to 5. Okay, and now I want to call all the rows. If suppose I want to know all the rows of first column. Okay, so or I want to know the first row, okay, and all the columns of this vector. So this will tell the MATLAB to calculate the first row of all the columns. This semicolon at the place of the column will represent that this is all the columns. If I write a digit over here, suppose I write 4 over here, so it means that first row, one means one row, first row, and second is the number of columns. It is fourth column. Okay, so this will represent the first row and fourth column. So first row means this row, and fourth column is this number 4. So it has written the value number 4 to it. Okay, if I want to call all the columns, okay, so I write first row and put a semicolon over here and close it with the parenthesis. It will call all the columns of first row. Okay, so all the columns of first row. So this is called indexing. This is called indexing, and indexing is very frequently used in MATLAB program. Okay, so you have to learn how to do the indexing. Okay, if suppose I have written another matrix which is n equal to 1 to 9. Okay, so this is another vector. Okay, 1 3 5 7, and I want to call suppose fifth element of this. So fifth element is 9. Okay, so this is how you can call only a single element by using this command. Okay, within the parenthesis, and this the index will be the value of that whatever will be the position of that element. The position of element is 5. So you just write 5 over here, and it will return the value of that element. So fifth element is 5. If you want to call all the rows or all the columns, you can put semicolon. Oh, sorry, colon. Okay. If you want to write a particular element of a particular row and column, then you index with like this. Okay. So this is the method to use to do the indexing. Another important parameter that rather we call it as a command that we use while doing the MATLAB programming is to calculate the size of a matrix. Okay, so in order to calculate the size of the matrix means the number of rows and number of columns. Okay, so how to calculate the size? Suppose I want to calculate the size of this matrix NB. Okay, so what it will do? Size will tell us the number of rows and number of columns in the matrix or a vector or matrix or any type of array NB. Okay, so I have put size parenthesis NB, so it will return the number of rows and columns. Okay, So for number of rows, I have assigned a variable R, and for number of columns, I have assigned a value C. Okay, and the value of rows and column will be stored in these two variables R and C. Okay, so rows is 1 and column is 5. So NB has 1 column, 1 row, and 5 columns. That what it represents. Now working with the tables. This is how we write a table. Okay, we have created a variable input main. Okay, and we start our table with curly brackets. Okay, then this is the first element, the first cell. Okay, in a table, the first cell is this. The first cell is a text because a string, because I have put it under this quotes. Okay, if it is put it under quotes, then it is a character value or a string value. Okay, so it is a string value, design data, and other are blanks because these are blanks. If I write anything over here, if I write say anything MATLAB, so in the second column, the MATLAB will be written. Or if I leave it as a blank, the second column will be blank. Okay, and this represents the termination of the first row. Okay, similarly for the second row, I have write serial number, description, value, unit, and for the other rows, I have written all these columns, and I have terminated with this this variable by this curly bracket. Okay, so this is how a table will be created containing all these inputs in a variable input main. Now I have to store this variable in a string. So with this command, so first let me execute this. Let me execute this. Okay, so you can see over here. See in your workspace, a variable is created with the name of input main. Okay, with the input name main with 4x4 cell. So there are 4 columns and 4 rows. Okay, so 4x4 cells. Okay, if I double click it, I can see the content of this variable input main. Okay, what is the content? So first cell is design data because I have written design data over here, and other are blanks. So other are blanks. Second is serial number, and this is how your table is. This is not in the form of a table yet. Okay, looks like a table, but it is not in the form of a table. The table is stored in a variable. You cannot export this in a spreadsheet. Okay, for exporting it as a spreadsheet, you have to calculate a string. So I have type another command, calculate dot input main. Okay, so I have created a string named calculate. In that string, I have created a variable input main. Okay, and the content of this input main will be the content of this variable input main. Okay, you have understood this? So let me execute this. So when I execute this, you can see a string is created with the name calculate over. Okay, if you double click it, it will show you the contents. What is the content? The content is the variable input main. Okay, so it has created input main in a string, or you can call a structure table. Okay, structure. So it has calculated a string name calculate, and within the calculate there is a variable input main, and the content of this variable input main are these variable. Okay, so if you further double click over it, it will show you the same data which is contained in this input. So this is how you can make a structure or make a string and put all those variables and create a new variable within the structure. Okay. Now a structure can be converted to a table, because in order to export your table, you need to create it in a table in a MATLAB format. So to create a table in a MATLAB format, you have to execute this command. You have to execute this command. So this command is save. What is this? This command is save results.mat. So what it will do, it will create a .mat is the format for table. So it will create a table named results, and in that table the contents are the contents of calculate. Okay, so it will calculate a table containing all the contents of calculate. Okay, press enter. So it has now created a table named results, and in that result the contents are the contents of calculate. Now in workspace you cannot see your table. Okay, you have just created a table named results, but in workspace you cannot see the table name results. Why? Because you have just only saved your structure as a table. Okay, in order to see it, you have to load it. Okay, you have to load it. So now you can see. Now you can see your results. Okay. Okay. So how to execute for loops and switch statements? I have already described it in my presentation that how this for loop works. Okay, suppose we want to calculate a factorial of any number given by the user. Here the factorial of 5 is calculated because I have write n equal to 5 over here. Okay, so in order to calculate this, the factorial of the value can be changed. You can, if you want to calculate the factorial of 10, you can write 10 over. Okay. Now initialize your product, your variable run product with the value of 1. You just keep in mind that if you are calculating product and you want to initialize your variable. So when you calculating a product, you initialize your variable with the value 1, with the scalar value 1. Because when you calculate a product, 1 multiplied by any value will give the same answer. So you initialize your value with the 1. And if you are calculating the sum, then in calculating the sum, you have to initialize your value with this. So this you have to keep in your mind. Okay. If you don't do this, if you don't initialize your value with a scalar provided by you, then it will take a random number and random number will give you the wrong answer. So while calculating the product, you have to initialize with the 1, and while calculating the sum, you have to initialize it with the 0. Okay. So for loop, okay, can be run by using this command. I will give you all these commands. Okay, the coordinator will provide you all these commands. You can run it. Okay. Now I have to discuss a script file, how to write a script file and how to do complex calculations. Okay. So for that, I have created a new file, procmat.m. Procmat.m is a script file. Okay, in that script file, I have written some commands. Okay, so I will tell you what these commands mean. Okay, so let me explain it one by one. Now, what is the purpose of this script file? The purpose of this script file is to ask the user to provide a data sheet, okay, in the form of a spreadsheet, Excel file. The user will provide that Excel file, and then whatever will be the data of that Excel file, your program will going to read that data and store all the variables. Okay, this is what is the intention of this program. Okay, the first is clear. The command is clear all and CLC. This is used for clearing the command window and the workspace, followed by a comments. I have written some comments over here. Okay. Now the main program starts from here. The first is UI wait message box, and in the message box, this is written. Browse Excel file for evaluation. So this command is used for displaying the message box. So when this command is run, a message box will display, and in that message box, this is the message. Okay, this is the message. Browse Excel data file for evaluation. This will tell the user to browse for the Excel file. Okay, if you do not run this command, what will happen? The command will run, but user will not know what has to do with that command. Okay, user will not know what to do. So you have to tell your user, you have to interact with your user. In order to interact with your user, this message box comes into place. Okay, so you have to use this message box very frequently. Okay, because it is required for interacting with the user. So this will tell the user to browse. The user will browse the path of the file. So the path of the file and the file name will be stored over here. So this command, what this command will do? This command will get the XLS extension file. Only those files which have the extension of XLS. You can change this extension. If you want to get the text file, you just write txt over here. If you want to get the PDF file, write PDF over here. I want to get the XLX file, so I have written over here XLSX. So this command will get the XLX file and store the path of that file over here. Okay. Now I have created, this command will create a file name based on the file name provided by the user. Now the user will only browse the path of that file. Okay. The file name will be chosen by the program. This, if you don't provide this, then you have to give the file name yourself. Okay, you don't want to give the file name yourself. You want the user to just give the file, the location of that file, and all those file names, all those variables will be sorted out by the program itself. So this command will help in sorting out the name of the file, name of the sheet. This will extract the only sheet 1. Okay, if you want to extract sheet 2, then you can give sheet 2. If you want to extract sheet 3, then you can extract sheet 3, or whatever will be the name of the sheet. So I have just created this sheet name, sheet 1. So it will only extract the sheet 1. Okay. Then this command XLS read file name 1 sheet name. Okay, the sheet name will come from here, sheet 1, and file name will create from here. Whatever will be the name of the file. Okay, so I will execute this command. I will do this. Okay, so what will happen? I have created 3 variables: numbers, strings, and raw. It means whatever the data is written by, whatever the data provided by the user, the numeric values will be stored in this variable numbers. Okay, the string values means whatever the value of name, the characters value, will be stored in the variable name strings. And all the data, okay, all the data, complete data with strings and numbers is stored in the variable raw. Okay, this command will do that for you. Now next I have used if and else statement. Okay, if statement. If statement is used when you have to provide some condition. If that condition is satisfied, then that command will run. If that condition is not satisfied, then the command will not run. So you want to check that whether the file provided by the user is empty or it is filled with numbers. So it will check it is not empty with numbers. Then what will happen? It will create a structure, new data 1, and within that structure, a variable is created, which is new data. Okay, data. And in that data, all the numbers containing in your file will be stored. Okay, this command will do that. So in a new data 1, okay, a variable is created data, and in that variable data, the numbers will be stored. Similarly, for the value of the column headers, we call it as a column headers, whatever the name of variables provided by the user, all those are stored in the column headers. Okay, so this command will store the column headers for you. Okay, now let me just run this command. Okay, I am suppressing it, and I'm just running this command. Okay, so the first was message box. In message box, it is asking the user to browse Excel data file for evaluation. Okay, so when I press OK, it will ask the user to browse for the file. Okay, so whatever will be the location of the file, you can browse through the location and give the data file. In my case, I am just providing it a test data 1. And the extension will be XLSX. Okay. Okay. So if I press OK, it will just create it has stored the file. Okay. So up to here, the commands does only display a message box and ask the user to get the Excel file, and it will read the file. And now see over here, the variable numbers stores only the numbers. Okay, so there is a variable numbers. Strings stores all the character values, so there is a variable strings which stores all the characters value. And raw stores all the data contained in that Excel file, so there is a variable called raw. In this raw, all the data files, all the data is. Further, if you suppose want to analyze your data, if you want to calculate minimum maximum value of your data, if you want to calculate mean of your data, if you want to calculate a standard deviation of your data, if you want to calculate coefficient of variation, okay, and any other statistical value you want to calculate with your data. So for that, I have provided some commands over here under the defining data. Now what will it do? Now your data is raw. Okay, your data contains all the numbers, all the name of variables. Okay, but you have to separate all the variables and separate all the data so that your MATLAB can work on separate variables. Okay, because MATLAB works on the variables. Okay, you can call the variables. You cannot call all the raw data. You have to tell the MATLAB what that data contains. So in order to do that, I have created a for loop over here. This for loop, what it will do, it will calculate the size of your new data. Okay, the size new data contains all the data. Okay, all the data. New data contains all the data. Okay. Now it will calculate the size of the new data of column headers, and based on that column headers, it will create the variables. Okay. Then based on the numbers, the data, suppose your data is this. Let me call new data. Okay. In new data, there are two variables. One is data and one is column headers. Okay. In data, all the numbers are here. Okay. And in column headers, only the name of the variables are there. So the variables are x1, x2, x3, x, y, and z. Okay, these are the column headers. The range of values of x1 are stored in this data. So the first column represents the range of the values of x1. Okay. The second column represents the range of the values for x2. The third column represents the range of the values of x3 and so on. Okay. So this is 6 variables. So 6 columns are there. And the whole data is over here. Okay. So your numerical data is stored in the variable data, and your name of variable is stored in column headers. Okay. So what this program will do, this loop will calculate the minimum. In this one, I have calculated the minimum value of your data, and data, it will run. I have denoted I over here. Now what this will do, this loop will start from 1 and go up to the number of variables. The number of variables are 6. Okay. So it will run from 1 to 6. So for first value, it will calculate the all rows in the data for the first column. Okay. So in the data file, in this data file, it will call the first column and all the rows. Okay. So what we need in this data file, the first column and all the rows. So it will calculate the minimum of all this data. So whatever will be the minimum value, this will be represented with this command, and it is stored in data evaluation structure under the variable minimum. You can find this over here. Okay. Similarly, for maximum value, I have created another for the maximum value. For the minimum mean value, I have created another for the mean value, and so on. Okay. If suppose you want to sort your data and extract some values from your data, suppose sometimes we do non-linear regression or artificial neural network or any other optimization techniques. So we collect some training data and we collect some testing data. So I have created some commands over here. What it will do, this command will sort the training data, 80% data as the training data and 20% as the testing data. Okay. So for that, I have created two commands over here. So this is the use of indexing. Okay. This is the use of indexing. Okay. Because in indexing, what you do, you just extract the values of particular number of rows of particular number of columns, and that those values you call and stored in a different different variable. Okay, so this is the use of indexing. So for that, for indexing, I have created that 80% data will be stored as training and 20% will be as testing. So many a times you come across these type of problems where you have to sort your data. So these commands will help you while working with the indexing. Okay. So this fit, what it will do, I have divided the whole data into 10 parts. Okay. For 80% training data, I have taken 8 components over here. First component, first to 10, then 2, then 3, then 4, 5 is for the testing. It means what does it mean? 1 means the first element will be the training data. 2 means the second element will be the training data. Third element will be the training data. Fourth element will be the training data. But the fifth element will be the testing data, because 5 comes under the testing. TST means testing. So fifth element will be the testing data. Then sixth element will be the fitting data, means training data. Seventh will be the training data. Eighth will be the training data. Ninth will be the training data, and last will be the testing data. So it means 8 elements are here for the 10 parts. I have divided in 10 parts. 8 elements are in the training data and 2 elements are in the testing data. So this is how I have divided into 80% and 20% training and testing data. Now what I will do, I will pass this 80% and 20% for indexing. For that, I have created another structure which is named as data sort. Okay. Within that structure data sort, a variable is known as train. Okay. This variable contains all the data for all the variables used for training. And this test will contain all the data from all the variables used for testing. Okay. So 20% data for all the variable will be stored over here, and 80% data for all the variable will be stored over here. Okay. And this is how what I have called the ith element of that variable. Okay. And I have put this fit means 80% data over here for all the rows, for all the columns. Similarly over. Okay. So what it will do, it will sort your data. Okay. It will call all the rows of each variable and stored it in the training data based on this 80% or 60% or 70% training and testing. So it will sort your data. Then you can, whatever will be the purpose, if your purpose is to do ANN, artificial neural network, to run the artificial neural network, then you can run artificial neural network. If your purpose is to run regression problems, then you can run regression problem. Then you can design your program accordingly. This represents the use of switch cases. Okay, switch cases. How to use the switch cases. For that, I have simply defined a program for area calculation of a circle. Okay, so what it will do, it will ask the user whether he wants to calculate the area of circle or not. If he wants to calculate the area of circle, then the program will ask the radius. Then if he enters the radius, then the area will be calculated and it will be stored in your table. Okay. Now last is how to export your data to the table. Now let me execute this program. Okay. Let me execute this program. It will show what this program will do. Okay. So let me run this. So first it will ask user for browsing the data file, Excel data file. Okay. So I press OK over here. So it is now asking me to browse that file. Suppose I give some data. I am giving this scour data that I am giving. Open. So it will calculate all the columns. It will calculate all the headers, and it has given me a message: data loaded successfully. So it means that whatever the data I have provided over here, the data is loaded successfully. Okay. Now next, it is asking me whether to calculate the area of the circle or not. If I press yes, it will calculate the area of the circle. If I press no, it will give me that user does not want to calculate the area. If I press cancel, it will just return back to the original program. So first, let me calculate the area of the circle. I have written yes. Now in the command window, it is asking me enter the radius of circle in meter. Suppose I write 5 over here. 5 is the radius of circle in meter. Then I press enter. Results are saved successfully. Okay. Now my program is complete. Okay. Now it is asking me whether I want to export my results or not. If I press yes, this will ask me to give the path of the file where I want to export my results to. If I press no, it will tell you that the user does not want to export the results. If I press cancel, it will return back to the original program. So now let me first save my results, export my result. Now I have pressed yes, so it is now asking me to provide the name of the file where I want to save my results. Suppose I give the file name as RES for the result and press save. Now it is now saving my results. All the results will be saved, and when it is completed, it will show the results are saved successfully. Now it is taking some time. So that's why I have described the type of integers and type of double and different types of unsigned integers to save the space. If the space is saved, then your program will run quickly. Okay. So results saved successfully. Now my results are saved successfully. I press OK. The program is ended. Now I can see in my folder that there is a file, Excel file, which is created by the name RES that I have provided. And in this Excel file, if I open it, there I will find all the results that I have created, all the tables. Now it has created 3 sheets. Sheet 1 is created by default. It is blank sheet. You can delete it. Okay. This is a default sheet. You can create this. You can also store your results in the sheet 1. But in my program, I have kept this sheet 1 as blank. Okay. I have created another sheet named data evaluation. Data evaluation, what it do? It will store all the data, all the variables, not the data, but the variables. So all the variables are here. Okay. And it will represent all the values that I have calculated. I have calculated minimum. So minimum of this variable is 6. Minimum of this variable is 0.35. This all calculated by the program, and then all those values are written over here. Then the maximum value, then the mean value, standard deviation, covariance. So these are the statistical parameters I have calculated for my given data for all the variables. So it has stored all the values over here. Okay. Area, remember I have provided radius 5. So it is giving radius 5 over here and the corresponding area in meter square over here. So the commands for these are over here. How to save the data and how to. Remember, in my presentation, I demonstrated one slide where I have shown you how to save the table. Okay, so I have used that particular command to save the table and write the table, and here I have used it. Okay, the one way to create a table is that way. That is the raw way that I have shown over here. Okay, yes, here. This is to write the table in a raw form, but this will take time. Okay, and here you have to define all the headers, all the column headers by yourself. Okay, but you don't want to do all this. You want the program to create all the headers. Okay, so for that, what I have done, I have created structures and then converted all those structures to table. This command, what it will do, it will convert my structures. Structure means those structures which I have created. Okay, in which all the, suppose this structure. This is one structure. New data 1 is a structure which contains two variables, data and column headers. Okay, and this command will convert this structure into a table. So I have converted data evaluation into table, and I have converted reserve area into table. So when this command is run, the next command will be result saved successfully. Okay. Now I can demonstrate you if I press, what will happen if I press no. So let us run the program. And run the program, it will ask you for the file. Suppose I give this test data 1, open. It is now processing that. Now data is loaded successfully. Okay, up to here you have just loaded your data and data is loaded. Okay, up to here what has happened? Suppose in my test data file, there are 4 variables that I have shown. In my data file, there are 6 variables, x1, x2, x3, xyz. So up to here, what it has done, it has separated all the variables and it has separated all the numeric data. Okay, and it has loaded in the separate variables. Okay, up to here it is done. Now next, it asked me to find that to calculate the area of the circle. Now I don't want to calculate the area of the circle, so I press just no. If I press no, it says that area of circle not calculated because I don't want to calculate the area of circle. Now it is asking me, do you want to export results? If I press no, what will happen? It will say that exporting results aborted by the user. Okay. Now I can see you. I can see where this command is. Yes, over here. Now for the area calculation, what it will use? It will ask, do you want to calculate the area of the circle? This is a question dialog box. Earlier I have used message box. Okay, here. This is a message box. It will just display a message. Okay, display a message. Now question box will give you extra, will display a message box as well as will give you some buttons to respond. Okay, question dialog box will do that for you. Yes, no, okay, like this. So question dialog box will ask whether you want to calculate the area. If the user say yes, then switch answer 1. Answer 1 is yes, then switch will go to this case yes. In this case, I have written the formula for area calculation. Okay, for that, it will ask the user for the radius, enter the radius of the circle. Okay, then if suppose user want to input the name of the, so write the name of the name of any candidate, say. So here write the name of the candidate, and since the input is a string or a character, so you have to write S over here. S represents the string. So whatever will be the value entered by the user, this will be stored as a string. So if you are getting the response in the form of a character or a string, then you have to write this additional parameters. Okay, S underscores for the character type and a string type. And if you are taking the input as a numeric value, then you do not need to provide this extra comment. You just leave it over here, close it by parenthesis. So this will get the value in the form of double. Okay, double data type. It means that numeric value. Now this R value will be stored in a structure which is named results. In the results, this variable is created, which is the name by the name of radius. Okay, and this is assigned as a value R, which is provided by the user. This command is doing that. The next command, in the same structure named results, I have created a variable. Okay, to create a variable, this is the extension, this is the syntax that we need to use. The first is the structure, then dot followed by the name of the variable. This is the way how to represent a structure with a variable. Okay, so results dot area means the structure is results containing the variable name area, and it calculates area by this. It calls this function C area. And now what is this function? I will demonstrate this function. This will calculate C area, and in the input argument I have provided the radius over. Okay, now what is the C area? C area is a function. Now my program is calling the function over here by this syntax. What is the function? The function file is this C area. I will also share this this function file with you. Okay, so remember, in my slides I have described that to write a function file, start with the function. Okay, then the output argument, this is the output argument, which is area. It is a variable area equal to the name of the function, which is the same as the name of the file. The name of the file is carea.m. So the name of the function should be same, followed by parenthesis, and under parenthesis it is closed by the input variable R. So this is the syntax of the function. Then some comments. These comments, whenever you type help, these comments will show you how to do the calculation and how to call the function. Okay, and in the body I have written formula to calculate the area. Area is pi into R into R, pi R square. And to terminate the function, it is the end command. It is terminated by the end command. So what it will do, it will calculate the area by this formula, and the value is stored in this variable area. Okay, and this is then transferred back over here. Whatever will be the value of area, it is transferred over here, and it is stored in this variable area under this structure results. Okay, whenever you want to call this variable, just write results dot area and the function is called. Okay, if you write results dot area, then whatever the value is stored in this, it will come. Okay, it will be called like this. Say R is equal to results dot area like this. Okay, so R will be done. It is showing undefined because I have not calculated the area, because I have pressed the answer no. Okay, because user does not want to calculate the area right now. So that's why it is showing the undefined value. Okay, if you press the button yes, then it will calculate the area for you. Here what I am doing, I am storing this structure, okay, this structure results, and converting it into a table. So for that, I have created a table res area, it means result area, equal to structure to table. It will convert the structure into table, and the name of the structure is results. So this results will be converted into a table, okay, and stored in this res area. Similarly, this structure data evaluation 1. What is data evaluation 1? Data evaluation 1 is this. It contains all the variables. It contains the parameters, statistical parameters that you have computed, and the values. Okay. So this structure will be converted into the form of table, and this table is saved with the name res data eva. If you want to export it, if you press yes, then what will happen? It will ask for your name of the file. If you, whatever the file you provide, the name of the file you provide, it will store it in the name, file name 2, okay, and the path. Then this file name 2 will be used to write a table. This command is used to write a table. You have already defined a table over here, res data eva and res area. You have defined this table. So you just have to write your table in the form of Excel sheet. Okay. So this write table command will do that for you. Use the command write table. Put the name of the table. Then the name of the table is res data eva. Then the name of the file which you have chosen for saving the results. In my case, I have chosen res. So the name of the file is res, will be put over here. Whatever will be the sheets, the name of the sheet that I have described is data evaluation. So you can see over here, the name of the sheet is data evaluation. You can use any, if you want to give it as a name, the name as sheet 2, say. So it will write the sheet 2 over here. Okay. This is for you to do. Then next, this res area, this table will be written under the same head, res, okay, under the same head, res, but in the different sheet. If you don't provide the name of sheet over here, what it will do, it will overwrite the previous one. So you have to mention the name of sheet also. So it will create a different sheet, okay, because you don't want to overwrite all the values. So if you don't provide the sheet name, it will overwrite all the values. So just provide the name of the sheet. It is area, and write table will write all the contents of this table into an Excel sheet. After this, if it is all completed successfully, it will the message box will display that results are saved successfully. If you press no, the message box will display that exporting results are aborted. So this is a demonstration to show how to write a script file, how to write a function file, and how to program your script file intelligently so that the user can interact with that. Okay. You have to define the statements, and you have to use the commands in your script file so that the minimum manual work is required by the user. All the work is done by the machine automatically. Okay. So write the program in such a way that user just have to give minimum input as possible. The work should be done by the machine automatically. So you have to design your programs. And for that, just use loops, for loops, and do while loops, statements, and all. So this is the end of the hands-on in script and function files. If you have some query, then you can ask.
Dear participants, if you have some question, you may raise your hand or type in the chat box. Seems there are no questions. This session was very informative and interactive, and the participants must have gained a lot from this, and they will use this knowledge in their research, and this all the information provided by the resource person can be very useful. So I would like to thank Mr. Mohd Danish, our resource person, for taking out time from his busy schedule and giving such an informative lecture. So thank you. Thank you, Danish sir.
Thank you.
Okay, so
Okay, so with that, we come to the end of second session of day 4.